Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be talking about unsteady flow, specifically simulation options, part 3. This will be the third and final part of discussing simulation options. All right, so what I mean by that is if I have my HEC RAS open right here, I've got my files, my geometric data, and then if I go up to Run, Unsteady flow analysis, options. What we've done already in parts 1 and 2 is started from stage and flow output locations and then gone all the way down to computation options and tolerances. So in this lesson, we're going to finish things off here from output options down to view runtime messages. We'll start off with output options, which is right here. So go ahead and click this. This dialog box allows us as the users to specify special output parameters that are beyond the normal default output data. As you can see across the top, we have a few different tabs. Restart file options is the first one, so I'll just talk about them across the way. This tab allows the user to write out an initial conditions file or files, sometimes called hot start files, with a .rst file extension. A hot start file can be used to set the initial conditions of the system for a subsequent run. So like I said, this is going to generate a .rst file. One way to do it is to click the checkbox and then specify the data. Write initial condition file during the simulation. So this is a time during the simulation where the .rst file will be created, or the checkbox at the bottom is just to write an initial condition file at the end of the simulation, in which case you don't have to specify exactly when that .rst file gets written. Let me go ahead and show you what the model looks like real quick. What I'm doing here is I have a 24-hour simulation starting on January 1st, 2025. It's going to go for 24 hours. There is a geometry file, there's a flow file, and of course the plan. Everything here says lesson 30. So I'm going to go ahead and open up my project file. I don't have any .rst files here right now, but that will change. So let's go ahead and add some. I'll go up to options, output options, and then for restart file, hours from the beginning of the simulation, I'm going to say 12 hours from the beginning of the simulation. And then I have the option here for second and additional restart files. So you can create a restart file every X hours after that first restart file. I'm going to go ahead and say, let's go 6. So what that means is I'd have a restart file that's created 12 hours into the simulation, a second one that's 18 hours into the simulation, 12 plus 6, and then a third one that's 24 hours into the simulation. Right here, I see the file name. It's kind of grayed out, but it says lesson 30.p01. That's for plan p01, and then the date time, and then the .rst file extension. So I believe this will output to my project directory, but let's just go ahead and run it and see what happens. So I'll click OK, and then I'll click compute. Everything should run here. Okay, so that ran. I'll click close. Now let's check that project directory. And sure enough, here we have the 3 hot start files, or restart files. It ends with a .rst, and you can see it's labeled appropriately with the project name, plan, and then the date time. So let's see. This would be the first one that's at 12 hours into the simulation, 18 hours into the simulation, and 24 hours into the simulation. If I go right click and check out what that looks like, it is not text friendly. That .rst file will be used in boundary conditions when setting up initial conditions. So I'll just go ahead and show you where that is. If you go to, let me close this, edit, unsteady flow data, and then in the initial conditions tab, you have this restart file name right here. So I'm going to just click that and then navigate to my RST file right here. Certain use cases for using this restart file is breaking up long simulations into multiple shorter simulations. And then the other one is for real-time forecasting. So say, for instance, you want to update it once every hour, once every day. You can use restart files for that purpose. Okay, so I'm going to reset my initial conditions to what they were and then go back to my options, which is output options. Okay, the next tab over is detailed log output. So what we have here is a number of checkboxes you can read it yourself, echo, input hydrographs, write parameter options and initial conditions, write detailed log output for debugging, and you can specify the actual date time or just leave it blank for the entire simulation. This tab allows the user to turn on a detailed output that is written to the log file. This log file can be viewed a couple different ways. You could just go up to options and then view computation log file. This is there's not a whole lot here because this is what we just ran. There's very little data here. It's the lesson 30 or the project name .bco01. Another way to view that data is to go to the project directory, and then here it is right here, BCO01 and 3 kilobytes. So not very large, but let's go ahead and turn on all those options and see how large the file is and then take a peek at it. All right, so back to our options and then output options, our detailed log output. Without thinking too much, I'm just going to check them all on. Of course, if you're using this, you would want to do a little bit more detail and an investigation into what data you want outputted. But I'm just going to click OK, click compute, let the simulation run again, and then I'll click close. Now I'll select options, view computation log file. And now we have a ton of data right here. I don't really like this interface because it's Notepad. So I'm going to close that. But let me go back to the project directory. And yeah, so we have 1700 kilobytes, so much larger than 3 kilobytes. And I can open that up in Notepad++ and then get all the data that way I want. Back to our options, output options. The third tab over is computation level output options. This tab allows the user to write out limited list of variables at the computation time step level. This is good for debugging. What you're going to do is say, click on write computation output level file. You can specify the date time if you want, otherwise it'll be for the entire simulation. And then down below here, we have additional variables. There are 2 default variables that will always be recorded. I've got the user's manual on the screen here. The 2 default variables you're always going to see is, it says default here and here. It's the water surface elevation and the flow rate. But then the checkboxes that you're seeing in that previous dialog box, I'll go back to in just a moment, is for water surface air, flow air, depth, invert, the velocity of the channel, and so on. So those checkboxes are here: water surface air, flow air, depth, invert, and so on. I'm just going to go ahead and check them all on. These values, these variables, will be written to a file in the project directory. Okay, here are the projects in the project directory before. So let me go ahead and run it. So I'll click OK, compute. Okay, that's done. So I'll close that back up. Back to the files in the project directory. And the file we're looking for is this HYD01. This is the file that has all those variables. So sorry for not pointing that out before. All right, so right click. Let's see if it has any meaningful data. Okay, so this is not convenient to look at in a text editor, but this is the file where those variables are saved. And once I figure out how to more easily view them, I'll let you know. All right, let's go back to our options and output options. The final tab is HDF5 write parameters. Unfortunately, the HEC RAS version 6.6 online user's manual doesn't mention anything about this tab, so I really can't provide any information in this video, but by all means, go ahead and try to figure it out yourself by reading the labels. That's what I would probably do. Yeah, okay. All right, let's carry on. Next in the options menu is friction slope method for cross sections. And I'm also going to couple this with friction slope method for bridges. So if you select one of these friction slope methods, there will be a default setting already. So in the case of cross sections, it's the second one, average friction slope. And I believe in the case for the bridges, it is the first one. Yep, average conveyance. But there are a few other methods for friction slope. You can read them here: geometric mean, harmonic mean, or hex 6 slope average method. Go ahead and select one of those 5 options if you want it to be different than the default. And then the last option here allows HEC RAS to actually select the most appropriate method. Okay, so I'll just leave it like that. The next option down is initial backwater flow optimization. So we've seen this before in a previous lesson, but if you have split flow in your model, such as at a junction, lateral structure, reach storage area, or pump, then you're going to have values or rows in that tab. So right now I have one lateral structure. It's over here. Actually, I wanted to move it over to the left side. So let me close that. Oops. Lateral structure. I'm going to move this to the leftover bank. This feature aids to find initial flow splits, such as the following elements, like I already mentioned: junction, lateral structure, reach storage area, and pumps. This same optimize checkbox, I'll probably always use, I like that option, is also available to check in the lateral structure dialog box within the geometric data. So it's checked on right now, click OK. Lateral structure and then optimization, and then here's that same checkbox, which is the entire dialog box is the same actually. Okay. Next up as a option, we have sediment computation options and tolerances. So right here we have a number of different options for sediment transport. This option, along with the other two options in the dropdown, which were just below them, which were down here, sediment output options and sediment dredging options. So these three options altogether allow the user to model unsteady flow sediment transport. That's both deposition and erosion. The user's manual does refer the reader to chapter 11 of the user's manual for more information on these topics. But for this lesson, it's a little bit too detailed than I want to go into. Okay, below that, we have check data before execution. That is just a simple check on, check off. So it's checked off right now. If I click it again, the check mark will appear. So boom, it's checked on. When this option is checked on, HEC RAS will perform a comprehensive data check prior to the unsteady flow compute. That's important because if the data is valid, then it will just carry on with the compute as normal. But if some of the input data for that compute is not valid, then there will be an error message that is displayed and the actual compute will not even be attempted. So like I said, I'm always going to have this one on. I don't see why you wouldn't want to have this checkbox on. All right, the last two here is view computation log file. We already saw this when outputting some data, but if you click on that, it will open up the output log file, which is that BCO01 file in my case. And it's going to have all the data that was output, either the default output settings or any additional output settings that you specified in your output options right here. All right, and then the last option is view runtime messages. So if you go ahead and click on that, you see the same messages that you saw during the last compute. So when you run the compute, you get these messages here in this computation messages box. And if for some reason you want to reread those messages from the last compute, then you can go up to options and view runtime messages. They're saved right there, but only for the last compute. All right. Well, that was it for this lesson. What we did was finish up part 3 of unsteady flow options, simulation options. Parts 1 were from stage flow and output locations through computation options and tolerances. And then in this lesson, part 3, we covered output options all the way down to the bottom, view runtime messages.